All right, looks like we're back for, what was it, part 5 of designing Naruto's Kunai knife. And we're going to start working on the 3D aspects of this knife together and see what we can come up with. All right, so I guess to start off, let's see. Hey, we had a problem at the end of the last episode where the shoulder of this blade met with the wood here. So that could either be solved in like a few different ways. One is increase the size of this so it sheathes around the wood. Oops. Let's go back to the sketch. As in, we have a line that goes from here. Where is it? There we go. So we have the wood continue straight on, which would be the ideal method of doing it because if you're a carpenter, you were, I guess, an arrow maker or fletcher, you'd want something simple. So just like one straight dowel. So if we were to do this, it would mean we'd have to increase the shoulder by a specific amount. Let's see. So let's let's play around with it real quick. So let's go 3 mirror. So we're going to create a variation or two that we can mess around with. All right, let's get rid of this. I guess we don't need all this in the back. We don't need it. Just get rid of all this. It's just excess if you think about it. I need to slow down the computer when I don't need to. Okay, 90 degrees. Oops. Was this adjusted as well? No, okay. So it's just that in dimension then. Alright, just to ensure that it's a straight 90. Sometimes you have to be a little fit. Inventor can be a little finicky, so you want to change things here and there. There we go. So let's do, what we'll do is just take this, mirror it over, using this one here. Get rid of that. It's not necessary. Alright, get rid of this. It's not necessary. So that's one solution to it. Just to let's just do this real quick. This is what we're gonna do. Cut that. Get rid of this. I do want to include those pieces in this. So let's just include the entire shaft. Mirror. So 3. Mirror. Apply. There we go. Let's get rid of that. Let's take this. Mirror. There we go. Okay, so now let's go ahead and get rid of these constraints. Okay. All right. think we'll want to have this end here anyway. So what would see, do we have an idea as to how thick the metal was? I do not have it pulled up. Let's see here. How thick was the metal wrapping around the shaft of an arrow? Connect was an arrowhead sheath so that how do you phrase this? It's just parts of an head. What do you call that part? I know modern, depending on the century, modern arrowheads, they go into the shaft as well as older medieval arrowheads, but like 14th, 15th century arrowheads, they wrapped around to prevent splitting of the arrow of their shaft. Okay, let's do this. For a medieval bobkin arrow head. How do you spell bobkin? A bodkin. Okay, not bobkin, bodkin. For a bodkin arrowhead, how thick was the pedal wrapping around the arrow shaft? Oh. Okay, so the socket was about 1 millimeter in thickness. Which is 0.039. So that's so what was that? That's a 32nd of an inch. So 0.0625 is a 16th, right? Yeah, and then 1/32 is 0.03125. So I think anywhere between 1 to 2 millimeters or 0.0625 to 0.3125 would work. All right. So if I was to do this, let's see. Let's go ahead and get rid of that. Just connect it. Okay. So in regards to what I plan on doing, so ideas I'll expand the the socket on this one, and this one I'll decrease the size of the dowel, which, let's see. So say do an offset, bring that down 0.0625. So do I want to do something like this? So there's pros and cons to both. The problem with this is you create a shoulder. So this is this right here. What is this? Where's that? I need that. Oh, are there two lines there? Is that why that happened? Alright, whatever. So we're going to create a shoulder like this. Yeah, what's... So this is... Come on. There you go. So when you do this, you're essentially creating what's called a stress riser. Because this point right here would be prone to cracking. And which means you would want to fillet this. So let's see, 11565. That should be 1/64. So you could do this. But still, you're weakening the structure of this material in doing so. So instead of it being one big integral piece, so let's do this. Get rid of the blade on this one. Get rid of that. Get rid of that and that. More than likely, just to get it in, chamfer this portion here. So this would be let's go 60. Nah, that's not enough. Instead of doing that, let's just do this. How big is this? 0.125, 0.0625. And so let's decrease that to 0.25 then. Okay. Cut. Get rid of that. Let's cut that down. Alright. Get rid of this. Zoom in. Get rid of the excess here. Is there an extra one here? There is an extra. Okay. Is there an extra one here? There is. Okay. Alright. So this is what we've got. Is there an extra one here? Nope. Alright. And so, let's take this, let's put this 1.5. Put it there. Okay. Now let's move this. Oh, come on. Okay, zoom in a bit. There we go. Let's get rid of that, get rid of that. Is there two here? Nope. Alright, let's do a quick fill it, fill it, fill it, fill it. Okay. So that's option one. The problem with this is twofold. So the grain's going this way, right? Which means even if you fill it this, that's prone to splitting in that direction. The best thing would be for this to be one homogeneous piece. Because, like, this will never be as strong as something with, like, an integral handle. But, or, like, with a piece of metal going all the way through. But you do want it to be strong enough to where you could safely hold this and not worry about it breaking, I think. So, if there's going to be a shoulder, it should be here. So I think that's what I'm going to do. Alright. Probably didn't need to do all that, but it's good to work things through. Alright, let's just go ahead and do it here. So increase this by 0.0625. Is it too thick? That's the other question. Should it be 0.0625 or should it be 0.03125? Let's say they had the capacity to make it thicker. Let's see, like, how thin can something be cast? Okay, so 1 millimeter is somewhat. So you can cast smaller than 1 millimeter, but 1 millimeter seems to be the ideal minimum just because I guess it's just the way they've set it up to be. Yeah, so in high pressure equipment, you can get to 0.5 millimeter. All right, so with that being the case, 0.625 might make it just easier for them in general. So increase that there, increase that there. All right, so let's get rid of this. I have to redo it anyway, so. All right, now let's go back to here. I only need to do it in one. I can mirror it over. All right, let's see. See if we can get the same dimension as we had last time. Hopefully it's not too much. If not, we can bring it down a bit. Okay, cut that out, bring it back, cut it. There we go. All right, let's see here. Bring it down. So is that too much? It is too much. Okay. What about half that? Or not half that, say 3/4 of the way. Now that looks like it works. But would this look better? Let's mirror this side over, see which one I like better. Do you like the aggressive curve more, or do you like the shallow curve more? This being the more aggressive. I don't need that anymore. We don't need that or that. All right, this is what I'm going to do. Let's get rid of this. Let's just do another set of duplicates just so we have an idea which one I like better. Okay. All right, so let's get rid of this. Mirror this over. Apply. Okay. All right. So this one should be the shallow one. Let's see. 0.0625. This one should be the steeper one. 0.9375. All right, yep. All right, so let's take this, move it, side the other one. Back on. Move. I'll move closer. All right, let's see here. So this is a shallow, top one's a sharp. Which one's better? Shallow one would give you more material. I guess at the end of the day, it doesn't really matter. Which one of these is a shallow one? Yeah, let's just do the shallow one. Yeah, let's do the shallow one. Mirror. Okay. Get rid of this. Yeah. Okay. Now, let's see. Let's fillet this. Okay. All right. Actually, don't need that. Okay. Okay. Just about done here. Okay. So I'm going to keep up with the 0.0625 and use this. All right. 0.0625 by 375. Eh, not biggest fan of that chamfer. Let's do this. Chamfer. See 0.03125. 0.25. Doesn't need to be that much. Just needs enough to where, there we go. That looks good. So let's increase that, increase that. Okay. Let's now do some fillets. There we go. Let's fillet this wood. Okay. And let's just do this one last thing to differentiate the two. Let's make this one. That's too much. 0.5, still too much. I guess it'll work. I guess what we had before we'll do. Yep. Okay, all right. And there it is. All right, so let's get rid of this. These are extra stuff. Yeah. And there is our completed Kunai body. Though in hindsight, this might be a good idea to shrink this a bit. Let's see. Fletching sizes. Let's see. Fletching. So what kind of feather do we want to model this off of? Maybe a foo-foo feather. Let's see. We'd like to have a straight fletching, I think. I guess let's go back to here. So here, so I do like the style of this type of fletching here. I do like the tail of this one. So maybe rise out. So this looks 3/8 of an inch. It's about 1/2 an inch. Hmm. Let's check flu. Flu feathers. Hmm. So this is what I kind of had in mind. Suppose that works. But what you want is a decent amount of drag to force it to point forwards. Let's see here. That's kind of what you want. Maybe just do a little bit of a curve there. I guess you could curve it there too. So let's see if we can pretty this up a bit. See if I can bring it in a natural curve. Okay. So see what 1 inch will do. Nope. Let's bring in an angle, say 5 degrees. Too much, let's do 2.5. Looks better. All right. Just fill this. See what 2.5 does here. Almost. C5. Don't want to go that far. Seems almost too round. Two might be the best of both worlds. So what if I increase the sharpness of this angle here? Maybe they're just too high. Let me bring them down a bit. Try that. So it's set at, what is this, 1.5? Let's bring it down to 1. Well, let's make it less exaggerated. Okay. Something better already, I think. Let's get rid of this. I'll mirror it over once I'm done. Okay. Let's take this. Two and a half. Two. There we go. Yeah, let's try 1 real quick, see what that looks like. See which, let's see, what did I like the best from this? So that does have a sharp angle. And that does look good. But, let's see, bring it up. Let's try 2.5 again. All right. It'll be something like this. I don't think they go to that much trouble for it. I think this is good enough for it. They wanted an easy release from the hands. Might go for a sharper angle here though. So what would that be? Is it 25? 30? That's what this looks like. Yeah, it looks pretty good. And I believe this had a bit of an arc to it. It was a bit of an S curve, but I think I can work on that later. It's a pretty good shape. Let's go ahead and mirror this over. And I believe that's it for now for this episode. We're going to go back and finally start tackling a few of the. I think we're going to tackle one more element, and that is the depth of the blade head from one more angle. Then after that, we should be done. And then we can move on to the 3D aspect of it. All right, but I'll leave y'all there and see you in the next episode.